Well, hey everyone, and welcome to our physics homework tutorial.
We hope you find this tutorial helpful in your study of physics, and if you do, please visit our website at www.physicsvodcast.com.
There you're going to find over 200 physics examples in every topic of physics. It's sure to help you get through that physics homework. We'll see you then. Hey everyone, here's your Sioux Falls physics teachers, and today we're looking at the magnetic force, and probably the most interesting part, or difficult part maybe, of the magnetic force, and that is determining its direction. So we have three different situations, and we're going to be practicing the right-hand rule to determine the direction of the force exerted on the particle in that situation. Now, in our first situation, notice that first of all, we have a magnetic field that is given. And it shows us two different ways to tell that the magnetic field is in or into the plane of the board here. First of all, it's actually just stated. B is inwards in direction. Secondly, also notice the little description here with the X's. Those are an abbreviation again for the magnetic field that is going into the board. Again, think of it as if you were looking at the back of an arrow that was traveling into the board. The X's represent the tip that you would see. Now, as far as actually figuring out then what direction that force is going to be, we have one other piece of information we need to look at. First of all, there is a proton, so it is a positively charged particle, and secondly, it is traveling to the right. Its velocity is in the rightwards direction. So now we're ready to try the right-hand rule. Again, first of all, be sure that you are using your right hand. Secondly, situate your right hand so that you have an open palm. And now we're going to line up each part of the palm with a certain part of our situation. Starting with the fingers, those represent the magnetic field. So our magnetic field was into the board, which means we need to orient our hand in this direction. Secondly is the thumb. And the thumb represents the direction of the velocity. So our velocity is to the right, our magnetic field is in, which means our hand should be oriented like this. The final step is to determine what direction the force would be, and for that, we simply move our hand in the direction of our palm. So if our fingers are in and our thumb is to the right, then our palm would move in an upwards direction. So to finish our problem here, on our positively charged particle in situation 1, we would have a magnetic force in the upwards direction. One final check that you can use to make sure that you have at least narrowed down the direction correctly is to remember that we have three quantities in magnetic force problems that all must be perpendicular to each other. So that means we need to be using all three axes. If I check our problem here, we initially had velocity in the x direction, that was to the right. We had magnetic field in the z direction, that was in or out. And so that means that as I put my magnetic force, that it should be in the y direction. It needs to be either up or down. So at least that can narrow it down so that I know what axes I'm looking for that final answer. Now let's move to the second situation, and in this case we again have a magnetic field that is labeled. In this case it's labeled upwards, as you can see by the arrows as well. And we also have a positively charged particle that is moving towards the right. So to practice our right hand rule again, we take our right hand, hold it in an open palm. This time, however, our fingers need to match the magnetic field And this time that is in the upwards direction. So I'll be holding my hand so that my fingers are pointed up. My hand, or my thumb, needs to match the direction of the velocity, which is to the right. And then finally, to move my hand in the direction of my palm, it must come out away from the board. And so to complete our diagram, we have a magnetic force that is out. And again, remember that our shortcut for that on the diagram is to draw a little circle with a dot inside. And again, that would represent the tip of an arrow. So if you can picture an arrow coming out of the board at you, this represents the tip, and that's why that is our shortcut abbreviation for the outwards direction. Also, using our double check of the 3 axes, we can see that this would make sense. The B, or the magnetic field, was in the vertical direction, so that's the Y, up or down. The velocity was in the X direction, to the right. And so it makes sense then that our magnetic force should have been either in or out to represent the Z direction. Finally, we have our third situation. And here we have one major change. First of all, the velocity is in the outward direction, as we can see again by our little shortcut. And secondly, the particle that we are dealing with is an electron. So it is a negatively charged particle. And this right away should be a big red flag that when you use the right-hand rule, if the particle is negatively charged, then you work in the opposite direction as your palm. Some people, by the way, would prefer to say, well, for a negatively charged particle, we're going to use the left hand, and you get the same result that way. But if you want to kind of keep with the right hand every time you do a problem, then you just need to remember that a negatively charged particle will move in the opposite direction as a positively charged one will. That means that we're ready to line up our hand. And again, first of all, we would start with the open palm. We need to orient our fingers first, which is the magnetic field, in this case towards the left. Next, we would orient our thumb, and our thumb should be coming out of the board. So we need to shift the hand to look like this. And now finally, we're going to move our hand in the direction of our palm. In this case, that is down. So again, if our fingers are traveling towards the left for the magnetic field, and our thumb is pointing out of the board for the velocity, then our palm would point down. So the direction of the force on a positively charged particle would be down. However, again, remembering that we have a negatively charged particle, for this particle then, the magnetic force would be up. And as our double check, we can again make sure all 3 axes are represented. We have the magnetic field on the X direction to the left. We have the velocity on the Z direction, which is out. And that means that the Y direction, up or down, should be one of the 2 options for the magnetic force. And we have ours in the upwards direction for this situation.